I'm Hannah. I'm going to talk to you today about our bowling kit. This kit has been designed so that you can do integrated STEM activities at every level. Whether you're in elementary school or high school, there are good uses for this kit to practice everything from counting to linear regression. But let's start with assembling it. The first thing you need to do is de-support the bowling balls. Simply take pliers and break the supports off the bottom of the bowling balls. You may need to sand it down a little bit to make it a bit more round, and if you're not finding that you're getting a consistent rolling motion, you can consider using a found or purchased ball, such as a ping pong ball or a golf ball. Those will also be useful if you are wanting to look into different variables of mass, if you want to look into diameter and so forth, and you can extend that even further by printing the bowling balls themselves at different masses or diameters when you turn off one-click printing in our website and either adjust the scale or infill of the models. But let's start with the basic kit and what you would do to set it up. Tape the ramp at your preferred distance back if you are worried about your students not having consistency in their data, and then select the bowling ball of your choice, place it at the top of the ramp, and then simply pull the release mechanism out of the way to roll the bowling ball down the ramp. There we are. I knocked over 6 of the bowling pins, and so you can have in elementary school have your students just practice counting the number of pins that were knocked over, and then as they advance have them practice converting that into a fraction, decimal, or percent of the total number of bowling pins, in this case 6/10, or practice reducing fractions. 3/5 of the bowling pins were knocked over, convert that to percent, in this case 60%, and so forth. So your students are getting a hands-on activity that is helping them practice and reinforce portions of a whole number. If you are in an elementary school, you can also use this to practice getting the students comfortable working with and graphing on the coordinate plane. One of the best activities to do with that is simply count the number of bowling pins knocked over at each of 10 distances, and you would simply move the ramp back a designated distance between each trial. Now at the middle school and high school level, you're going to want to do more than one trial at each distance, and this leads perfectly into scatter plots. And you can use the scatter plots then to practice linear regression with your students, have them develop a line of best fit or best guess, and from there take the slope of the line, analyze and interpret that slope to see if there are any trends found in the data as you move the bowling balls further and further away with each release. More than that, you can also get into different variables, such as the mass of the bowling balls themselves, the diameter of the bowling balls, and a great way to do that is to use a found object such as a golf ball and then print a bowling ball to have the same mass and compare how the two different diameters using the same mass affects the number of pins that are knocked over through a variety of trials. So as you can see, this kit has a lot of great uses for bivariate data, for analyzing that data, and for interpreting it. And we hope you enjoy using it from elementary all the way up to high school, and we wish you lots of strikes. Thanks for listening.